Okay, let's take a look at the next problem. Uh, it wants us to use loop mesh analysis to determine the current through the 2 ohm resistor. So right here. Now the thing is, we don't actually know the direction of this current. We don't know if it's actually going up or down. We see we have 2 batteries here, and we've got a couple of resistors up here as well. So using mesh loop, I will just go ahead and start writing everything out. So mesh loop is going to assume that we know 2 current directions, and let's say that I assume I know that the current going down here, I3, is going down. So I can say um, I1 plus I2 is equal to I3. Now, to write out my first loop equation, I will do negative 28 plus VR1 plus VR2, and that'll be equal to 0. Now if I come in here and replace V's with IR, I'll say I1 R1 plus R2. I have I1. Actually, we can do I3. Right, I3, because we're assuming I3 is going that way, and that'll be equal to 0. Okay, so now we can continue writing and see that if we do negative 28 plus 4I1 plus 2 I1 plus 2I2 is equal to 0. Because remember, we said that I of 3 is equal to I of 1 plus I of 2. So we'll just combine like terms, and it looks like we have 6I1 plus 2I2 is equal to 28, and that'll be our first equation. Okay, and then if we come over here for loop 2, we'll do the same process. We'll do negative 7 plus VR3 plus VR2 is equal to 0. And we'll replace it with V is equal to IR, where this will be I2 R3 plus R2 I3 is equal to 0. You remember we said I3 is I1 plus I2. Keep simplifying down. So R3 was 1, so just I2, and then R2 was 2, so we'll have 2I1 plus 2I2 is equal to 0. And then looks like we'll get 2I1 plus 3I2 is equal to 7. And this will be our second equation. All right, and we want to find, we have 2 equations, we have 2 unknowns. So we need to find both of these currents, so we can find I3 here. So I will use Cramer's rule. You can use plug and chug if you want. It's up to you. I will use the Cramer's rule just for the people who want to see it. So determinant. This is going to be 28, 7, 2, and 3. This will be determinant 6, 2, 2, and 3. This will be 28 times 3 minus 7 times 2. 6 times 3 minus 2 times 2. And that should give us 70 over 14. That will give us 5 amps for I of 1. If we scroll down a little bit and do the same process for I2, determinant, and we'll do 6, 2, 28, 7 over determinant, 6, 2, 2, and then 3. So give us 6 times 7 minus 28 times 2 over, we already found this value, so that'll be 14. That should give us negative 14 over 14. So therefore it should be negative 1 for I2. All right. So we got that. So now if we jump back to what we had before, where we assumed that I1 and I2 met up to form I3, we can say I3 is equal to I1 plus I2. If we just go plug those in, so 5 amps plus negative 1 amp. So I of 3 is equal to 4 amps. All right. And so what does this actually mean? We got a negative current. So that negative current implies that the direction that I chose initially was wrong. So the real current actually goes that way. The real I2 goes that way. And you might be wondering, okay, why? I've got a battery. Well, take a look. Your battery here is 28 volts. Your battery here is 7 volts. 28's a lot larger than 7, so it's pushing a little bit more. So it's going to push the current actually back into the battery on the right. Just a little bit of a conceptual way to think about it.